Hello everyone, I am Ananya. So today's my topic is Gaussian mixture model. So good afternoon. Today I will be representing on Gaussian mixture models or GMMS, a powerful method in machine learning used to discover hidden patterns and clusters in data, especially when we don't have labels. So let us start with what is Gaussian mixture model. GMM assures data is generated from a mixture of several Gaussian distributions. Each component represents a cluster or subpopulation commonly used in clustering, density estimation and anomaly detection. Uses expectations maximization EM algorithm to estimate parameters. So, a Gaussian mixture model assumes that our database is made up of combination of several Gaussian distributions. Think of each one like bell curve. Each of these distribution or components represent a cluster or a group in a data. So GMM are mostly commonly used in clustering, density estimation and anomaly detection to estimate the parameters of these distributions such as their mean and variance. GMM use a method called a expectation maximization algorithm or EM like k-means, which gives us hard cluster assignment. GMM gives us probabilities a data point might belong one cluster 70% and another 30%. So the next one is advantages of Gaussian mixture model. So what are the advantages? So let's look at the strength of GMMs. So first one is a soft clustering. It means every point gets probability of belonging to each cluster, not just one. Only one cluster it belongs. Means assigns probabilities to point instead of hard clusters like k-means. Second one is flexible shape modeling. It can model elliptical clusters of various sizes or orientations. So what it tells, unlike k-means, they can model elliptical and differently sized clusters. So third one is a probabilistic foundation. It provides a likelihood framework for evaluation. Means because of GMM are based on a probability, they offer a solid statistical framework for interpretation. So the next one is a handle overlapping data. It works well when cluster boundaries aren't distinct. Means they work well even when clusters overlap, which is common in real data. The next one and fifth one is scalable to high dimensions. It can be used for density estimation in large feature spaces. So GMM can be applied in a high dimensional spaces, making them useful for complex datasets like machine or audio. So the next one is a disadvantages of Gaussian mixture model. So there are 5 disadvantages. First one is a sensitive to initialization. So it means bad initial values can lead to poor convergence. So what it can tells us, they are sensitive to how we start. Bad initial guesses can lead to wrong result. Second one is assume Gaussian distribution, not ideal if data doesn't flow Gaussian pattern. So they assume that data flows a Gaussian distribution, which isn't always true. Third one is scan coverage to local optima. EM algorithm may not find the best global solution. So what it tells, the algorithm can get stuck in a local optimum and miss the best solutions. Fourth one is a computationally intensive. EM is slower than algorithm like K-means. So EM algorithm is computationally heavily, especially large data sets. Fifth one is a may overfit, especially with too many components or small data set. With too many components or not enough data, GMM can overfit, making them less reliable on new data. So the next one is a real world application of GMM. So first one is a speaker identification. So what it tells, in a speaker identification, they model voice frequencies to recognize individuals. The next one is a image segmentation. So for image segmentation, they group similar pixel colors or intensities. So the next one is a anomaly detection. It identifies data points with low probability under the learned mixture model. So what it can say, it says in anomaly detection they flag data point that don't fit any cluster well. So the next one is a astronomical data analysis. It used to detect galaxy clusters and stellar groupings. So what it say, in astronomy, GMM helps to detect galaxy cluster from large space spatial data. So the next one is a financial risk modeling. It model market regimes or assist returns with multiple Gaussian component. So in finance they model multiple market conditions like bullish or bearish based historical returns. So at the summary of Gaussian mixture model, it tells us GMM extend clustering through soft probabilistic assignments, flexible more complex distributions and computationally heavy. Third one is a broad applied in real world system that need probabilistic modeling. So what it say? To summarize, GMM are flexible and powerful tool for clustering, especially when we want a softer assignment instead of fixed labels. They offer more nuanced modeling of real-world data and require careful tuning and computation. Whether it's voice, images or space, GMM are used whenever we need to understand hidden patterns in unlabeled data. So this is our Gaussian mixture model. So thank you.